Good morning and welcome everybody. Thank you for joining us for our webinar today. My name is Ryan Blazik. I'm with Eagle's Environmental Support Division. Just going to be helping to facilitate this webinar. This is a webinar for or on the agricultural inventory planning and implementation efforts to reduce nutrient loading into the Western Lake Erie Basin. And this is part of a new webinar series that's put on by the DNR, Eagle, and the Michigan Department of Agriculture and Rural Development. But before we get too far, I just have a couple logistical things to go through. Just so you're aware, all lines are going to be muted during the webinar, so you'll be able to hear everything we say and us, but we can't hear you. You can submit your questions using the Q&A box in your Zoom toolbar at any time. You'll see that at the bottom of your screen. And we will have a Q&A session at the end of the presentation. And then also we're recording this webinar, so you'll receive a link to that recording here in a couple days, and you'll be able to review it again at that time. And with that, I would like to invite Michelle Selzer, who is the Western Lake Erie Basin Strategist with the Michigan Department of Agriculture and Rural Development, to kick things off for us today. Welcome, Michelle.
Great, thanks, Ryan. Thank you for everyone joining us today. We have about 452 people registered, so very happy and pleased to see that high level of interest. As Ryan mentioned, my name is Michelle Selzer, and I'm the Western Lake Erie Basin Strategist for the Department of Agriculture and Rural Development. And I also facilitate the Michigan DAP team. And they oversee the implementation of a wide variety of programs across the Western Lake Erie Basin to focus conservation in the right places on the landscape. Our goal is to work with the agricultural community to improve water quality conditions at the local level and ultimately Lake Erie. So for those of you that may not be familiar, in recent years, the Western Lake Erie Basin has experienced the reappearance of significant algal blooms, some of which are harmful to aquatic life, can present challenges to drinking water treatment, and are caused in part by excessive nutrients. To reduce the amount of phosphorus and nitrogen specifically entering the Lake Erie, Michigan released our domestic action plan in 2018, and we also developed a companion adaptive management plan in 2021. These two documents are meant to work together. The DAP is the guiding document that outlines 10 task-oriented priority objectives and actions that we commit to achieving under our 2015 Western Lake Erie Collaborative Agreement, as well as affirming our commitment to the binational goals outlined in the 2012 Great Lakes Water Quality Agreement. The Adaptive Management Plan was developed to outline a more structured framework to learn about the impacts of actions taken by the state to achieve our reduction goals, and then use this information to track our progress in a more formal way, as well as identifying gaps in our knowledge that pose challenges. When taken together, this adaptive planning process and approach is meant to strengthen our partnerships on the ground and pull in the same direction to accelerate conservation in the right places to improve water quality outcomes in the Western Lake Erie Basin. 2023 will be a very busy year of project implementation, so we wanted to continue to keep our partners and the public up to date on our efforts. As Ryan mentioned, this is the first series in a quarterly public webinar series, or first webinar in our quarterly webinar series, as a way to keep everyone informed. We'll be hosting our next webinar sometime in January, and for more information, please see the link. We have a Taking Action on Lake Erie webpage that you can get more information on. So now I'd like to introduce Thad Cleary with Eagle's Nonpoint Source Program, and he'll be providing an overview of the agricultural inventory effort underway in Michigan's portion of the Western Lake Erie Basin. And this is serving as a really critical key planning and implementation foundation for our collective work moving forward. With that, I'll turn it over to Thad.
Thank you, Michelle. Let me get the presentation pulled up here. And can you see that now?
Yes, we can see.
Looks good.
Thank you. Thanks everybody for joining this morning. Again, my name is Thad Cleary. I'm with the Water Resources Division in Eagle, and I work in the Nonpoint Source Program. The Nonpoint Source Program, we give out grant funding for developing watershed management plans and implementing those watershed management plans. And so this morning, I'm going to talk about an agricultural inventory process that we developed in the Nonpoint Source program. This process wasn't developed specifically for Western Lake Erie Basin. It was developed for our Nonpoint Source program. So we've been implementing this throughout the state in agricultural watersheds, but we're using this approach to address the issues that Michelle mentioned in the Western Lake Erie Basin. So the purpose of the agricultural inventory process is basically we're looking at fields' natural characteristics, what's on the landscape out there and crop fields. And along with that information is how is that field being farmed to identify those fields that have the greatest potential of contributing sediment, nutrients, pathogens to our surface waters. And I'm going to kind of give you, before we get into the detail here of the inventory process, just to give you a brief history of how we came about developing and why we developed this process. So in those grants that I mentioned, where we pay for the development of watershed plans, we give, say, a grant to a watershed council or a local conservation district to develop a watershed plan. And in that process, we found that, we were putting thousands of dollars and usually taking a couple of years to go through that process. And in the end, we would get information for an agricultural watershed like, that the watershed needs to implement filter strips and cover crops and nutrient management and no-till, and really stuff that we probably could have figured out really quickly just looking at the land use, but it really wasn't. The plans were not identifying where were those practices needed to get the improvement for water quality. And in addition to that, so since there was no site-specific information coming from that as well, when it came to implementation, it wasn't really, you didn't know exactly where to go to put those plans. So it was just putting information out there to the farmers saying, we have cost share available to implement these practices. And then basically you wait for those who want to do something to come to you and work with them. And so we weren't getting at, those locations that are likely contributing. So that's where this process came from. Also knowing that there's been studies done out there that show a majority of the pollutant loadings of sediment, nutrients, and pathogens come from a small percentage of the land base in a given watershed. So again, if you don't get those practices in the right spots, you're not likely going to see the changes in water quality that we're looking for. So we'll get into the process here that we developed in the Nonpoint Source program. And so the information that we're going to look at, the different field characteristics and farming practices, this is just a quick list, and we'll get into more detail on all of these. So we're looking at what's the field's proximity to a water body? What are the slopes within each of those fields? Where does surface water flow across those fields and eventually get to a ditch, a stream, or a river? What crops are the farmers growing on those fields? What kind of tillage practices do they use in the fall? Are they using cover crops or not? How much residue do they leave on the ground after planting in the spring? Which fields have filter strips? Which fields don't have filter strips between the crop field and the surface waters? Where are the concentrated animal feeding operations located, or the smaller operations, the AFOs, the animal feeding operations? Where are they located in the watershed? And also, where is manure being spread in the watershed, especially from the CAFO operations, because we actually know that information. So this is the kind of information we were looking to collect on a site-specific basis throughout the watershed. So to do that process, we basically came up with three components to gather that information. The first component is the Agricultural Conservation Planning Framework tool, that's the ACPF. The second component is a desktop analysis, and then the third component is a field inventory. So with the ACPF, so this is basically a tool, a model that uses LiDAR data and digital elevation models to determine where water is going to flow across the landscape. It's a model, but it's actually very precise, and because it uses the LiDAR data in figuring out exactly where water will flow. You can see in that top photo there, the blue lines, are the stream courses, and then the green lines are what the ACPF tool identifies where water is flowing across the landscape, across those crop fields, across the landscape. And that is one of the very most important parts, I think, of this, the ACPF tool is that component. And then in addition, it will can look at slopes, can figure out slopes because of that, the LiDAR data that was developed for each watershed, as well as what locations for practices. And we'll get into a little detail here. So the first place that we ran this agricultural inventory process was in the Bean Creek watershed. It was a grant that we had provided to the Hillsdale Conservation District to develop a watershed plan for the Bean Creek. The agricultural inventory process, we only ran it in the 3 sub-watersheds you see here, the Covell Drain, Lime Creek, and Silver Creek. The watershed plan was for the entire watershed, but the agricultural inventory process, the details, we ran it just in these 3 subs. And so that's what I'll kind of use as examples here to go through what information was collected. So with the ACPF tool, it's basically going to give you a watershed, identify where your stream courses are and what your watershed boundary is based off that LiDAR data, the digital elevation model. So this is just an example for the Lime Creek subwatershed within Bean Creek, where the stream network actually is. And then we take that information and we couple it with, we digitize all the crop fields within that subwatershed, the Lime Creek subwatershed. So for the ACPF tool to run, to have those fields, those crop fields digitized, as well as you'll see how it fits in with the field inventories here coming up in a few minutes. So we have all the crop field digitized. We know the acres of those fields. We know where they're located in the watershed. And then the ACPF tool, when you run the tool, it will actually take take the information and figure out what is the slope of any given crop field within that watershed. So here you can see on the top right, it shows you the mean slope of those fields. So you have anywhere from bright green is 1.2 to 2.2% slope, mean slope in those fields, up to 4.8 to 8.4% mean slope in those red fields. In addition to mean slope, it can also be broken out into what percentage of the fields is in a 1 to 2% slope, 2 to 5, 5 to 10, 10 to 15%, or greater than 15%. So it really breaks that information down field by field, kind of what are the slopes that are out there in each of those fields. Obviously, the greater the slope, the more potential for runoff, the more potential for erosion to be occurring. Another aspect, the information that it'll provide to us is, again, citing best management practices on the landscape. And this is an example of where the tool will identify where grass waterways potentially need to be installed. So it's taking those runoff lines where it's getting heavy concentrated flow that could potentially cause gully erosion. And then it will identify where that will be occurring and where grass waterways could be installed to basically convey that water across the landscape without it actually causing gully erosion as it flows across the landscape. On the left picture there, you can see the red line that shows where the ACPF tool called for a grass waterway, and you can actually see in the photo that there already is a grass waterway in a lot of the areas that the tool identified. So that gave us a lot of confidence that the ACPF tool is doing a really good job of identifying where grass waterways would be needed. So in addition to grass waterways, there's a lot of other components of the ACPF tool that I'm not going to get into the detail of, but it can identify where water and sediment control basins should be located. It can give an estimate on which fields are likely tiled. It can show where there's depressional areas where there's potential for wetland restorations to occur. So there's a lot of other detail there that conservation district, local staff who are working with farmers can take all of that detail that's being developed and use that when they're working with one-on-one with farmers. So our second component of the agricultural inventory process is the desktop analysis component. So here again, we have the field boundaries. We're going to look at fields next to waterways, filter strips, manure applications, and such. So the first one here, this is Covell Drain within the Bean Creek watershed. So this sub-watershed had 604 crop fields that were digitized about 16,500 acres of cropland in this sub-watershed. And so what we did here is we went through and identified which of those fields were within 50 feet of a surface water body that was identified in the ACPF tool. And you can see here there's 139 out of the 604 fields, a little over 4,000 acres of cropland, fields that were within 50 feet of surface water bodies. And then from there, we looked at those fields, and using aerial photos, identified which of those fields that were within 50 feet actually had a vegetated filter strip that the farmer had planted between the crop field and the surface water body. So it wasn't just a natural buffer in there, it was actually the farmer planted a vegetated filter strip. So right away, you can see with the brown fields there that are those fields did not have filter strips. Right away, those are areas that we could target for that practice, knowing that those fields are in close proximity and could benefit from having, water quality could benefit from having a filter strip placed on those fields. Next, in the desktop analysis component is looking at where are livestock operations in the watershed. So we did that for the concentrated animal feeding operations, the CAFOs. This information, Eagle has this information because we permit, Water Resources Division permits these operations, so we actually have this information. So this is the red diamonds there, you can see are the locations of the CAFOs in or near the watershed. We identified those near as well because some of the manure generated in those outside of the watershed could actually get transported into the watershed, so we wanted to show all CAFO operations in close proximity. And then the fields there you can see are identified. Those are fields that the CAFOs reported to us that they could potentially spread manure on. Now, it doesn't mean that they're going to spread manure on those fields every year, but in any given year, those fields could have manure applied to them from CAFO operations. And I will point out that this is not necessarily all the manure that is going to be generated at these CAFOs. They will manifest a lot of their manure, which means they will give it to other farmers or they will sell it to other farmers, and it will get applied to crop fields that are not under the control of the CAFO. And as of right now, we don't know those locations. Hopefully with the new permit, the new general CAFO permit, once that's issued, hopefully that information, it's in there right now. And if that permit gets issued, we will actually be getting the locations of the manifested manure as well. So we will have the field locations of where all the CAFO manure is going to be applied in any given watershed around the state. So in addition to the large operations, the CAFOs, we also went through aerial photos over scanning the entire watershed and identified where there were any other small, medium livestock operations or even hobby farms and where those are located. And not just we located them so we have a point of where they're at, but also then during the aerial photo review, was there anything we noticed, any potential impacts to water quality, whether it's feedlot runoff, livestock having access to a stream or a ditch, a dairy operation that you can see they have no liquid storage. So how are they handling their milk house waste, which is a liquid? Where is that being stored? How is that being handled? If it's an operation that has no manure storage, that means they're likely going to be spreading year round, spreading during the winter, increased risk from a water quality perspective. So we would document anything like that, any information like that for each of those sites as well. And then the conservation district would follow up, could drive by the operation, see if there's anything else it could see. And then those operations that were deemed to have some risk, again, that's where the conservation districts during the implementation could go and start talking to those farmers to potentially address those issues. So in the Bean Creek watershed, again, we did this for the entire Bean Creek, not just the 3 subs where the ag inventory is completed. So these were all of the yellow diamonds are where any small and medium livestock operations were located from the aerial photos, as well as we identified hobby farms. So some places with a few horses or a few livestock, much smaller than the small operations that we would consider AFOs. So we have all of that information documented. And again, any of those sites that there was potential water quality issues, that information is documented as well. Specifically for the Western Lake Erie Basin on this kind of the livestock issue, the Herb Foundation provided grant funding to the Environmental Working Group out of Minnesota, who actually worked on the ACPF, running the ACPF tool on some of the Huck 12 watersheds here within the Western Lake Erie Basin. But in addition to that, the Environmental Working Group also looked at area photos for the entire Western Lake Erie Basin in Michigan and identified where the small, medium, and large livestock operations are located. They did not do the hobby farms. They didn't go that far down. So what they did is, again, scanning aerial photos, identified where they were at. And then from there, they actually estimated by looking at barn sizes, how many livestock were at each of those locations, how much manure potentially is being generated there, and then how much phosphorus is in that manure that's being generated. And from that, they were able to figure out how much cropland would be necessary to utilize the phosphorus that's being generated from these livestock operations. So it gives us a good handle on, where manure is likely being applied in the watershed. And a lot of times, because the manure is it's not like commercial fertilizer. The farmers need to buy commercial fertilizer. The manure, they have to get it applied to the land, obviously get it out there. So it's more likely that some of those fields, the fields that are getting manure applications, it's a much chance that the soil phosphorus levels are going to be higher in those fields than where somebody's purchasing commercial fertilizer. So that's one aspect of, again, trying to figure out where we need to go to address the water quality issues here. And now the third component of our ag inventory process is actually the field inventory component. So this is actually where the conservation district staff will go out and drive the watershed and document what crops are being grown, what tillage practices are being used, are there cover crops being grown on those fields, what's the amount of residue left after spring, do they see manure being applied to those fields? That would get that information would be documented as well. And so this is an example of crops, the documentation of what crops were being grown in 2018 in the Lime Creek watershed. So you can see we have corn, soybeans, hay, wheat are your predominant crops there. And then in addition to the crop information, they also collect what fall tillage occurs on those fields. So this would be, they wait until after harvest is done, after all fall tillage would be done. You don't want to go out before it. So you usually wait till there's snow on the ground or the ground's freezing and the farmers are not likely to be back out there doing tillage. So this is anywhere from December through the following March, as long as there's not snow on the ground, that you can see that they can go out and collect this information on what tillage is being done. And the importance of collecting the crop and the tillage is, what that tells us is, if you know the crop that's being grown and the type of tillage, you have a good idea of how much residue is actually on those fields over the winter and early spring to reduce that runoff and erosion that's going to occur in those fields. So for example, if you had a field that was planted to soybeans and that field was chisel plowed in the fall, soybeans don't have a lot of residue to begin with left over after harvest. And then once they chisel plow, which is a very aggressive tillage practice, there's probably not a lot of residue left. So that would be, a field would be more risky than a field that was harvested, those corn that was harvested for grain, that would have a lot of residue on it. If that field is plowed or if it's mulch tilled, there's the likelihood there's going to be more residue out there to help reduce that runoff and erosion over the winter. So this is an example of the tillage that occurred in 2017 in Lime Creek watershed. You can see the two predominant, one was no tillage done. That's the green ones there. So there was over 13,000 acres that had no tillage done in the fall. And the other predominant practice was chisel plowing. Again, it's a more aggressive form of tillage that will likely bury a lot of the crop residue that was on the surface. And in this case, there was over 7,200 acres during the fall of 2017. So the next slide I'm going to show you is 2018 for the same sub-watershed. And kind of remember those numbers here: 13,000 no tillage done, 7,000 of chisel plowing. So in 2018, when the conservation district staff went out and collected this information, you can see that the no tillage acreage jumped up to almost 19,000 acres where there was no tillage done, and the chisel plow dropped down to about 1,700 acres. If you had only collected the 2018 data, you would probably look at this and say, well, these farmers don't do a lot of fall tillage in this area. The majority of the fields, there was no tillage done. But the reason is because in the fall of 2018, it was a wet fall. There was a late harvest. They couldn't get the crops harvested, which means they didn't have time to actually do the tillage that they may have wanted to do. So that's why it's important to collect multiple years of this data, because obviously farmers' decisions, what they can and can't do, a lot of that's going to be based on the weather and timing and when everything occurs. So to get a good handle on what's actually occurring, you really need more than 1 year of data. Probably even more than 2 would be helpful to have that. So in the spring then, the following spring, the conservation district staff would go back out. They would, again, they would document what new crops were planted. And in addition to that, they would document how much crop residue is left on the surface of those fields after the crops were planted, in this case, in the spring of 2018. So what we have them document is which fields have less than or greater than 30% residue. 30% residue is the percentage of residue. Above 30% is where you reduce the chances for runoff and soil erosion. Below 30%, you have increased chances for soil erosion. So that's kind of how we chose that number. We also documented fields that had 0 residue. Obviously, that's not good. Just wanted to have an idea of how many fields are getting so much tillage that there's basically nothing left out there in the spring after the crop is planted. And then we also had them document which fields were planted with a no-till method. So no tillage, there was no soil disturbance. They were just planted into the previous year's crop residue. Again, that is going to be, we know those fields are going to be over 30% residue. We just wanted to document actually how much no-till planting was occurring so that we could potentially track that over time if we went out in the future and did these inventories again, see how that changes over time, how many acres are under no-till planting. So at this point, we've gone through, collected all this information from the ACPF tool, the desktop analysis, the field inventories. And then it's trying to take that information and prioritize, okay, we'll get back to that whole purpose of the ag inventory is which fields are most likely contributing, sediment, nutrients, and pathogens. So this slide here is one example. It's not the only way to do this. There's a lot of information, but this is just one way we've started to kind of break this information down. What we decided up front is we were looking to try to identify somewhere between 30 and 35% of the highest priority fields in any given sub-watershed. So we started with the red priority field criteria. So we first looked at those fields within 50 feet of a surface water body that had fall tillage done in 17 or 18, or they had less than 30% residue in 17 or 18, or they had the potential of CAFO manure being applied to those. So we ran those criteria and came up with fields that met those criteria. That didn't get us up to our 30 to 35% of the acreage that we wanted for the watershed. And we also wanted to take into consideration slope. So then we ran the scenario, the green priority fields criteria, where we started with identified those fields that had a mean slope of greater than or equal to 3% from the ACPF tool. And they were also within 300 feet of a surface water body. We went further out because we figured increased slope, those fields could be farther away and they could be contributing sediment, nutrients, pathogens. And then we also applied our same criteria again. They had fall done 17 or 18, less than 30% residue, 17 or 18, or they had potential CAFO manure applied to them. And so when we ran those two criteria, we ended up, as you can see, there was 526 total crop fields in this Lime Creek subwatershed, a little over 24,000 acres. And when you add the red priority fields and the green priority fields, we're within that 30 to 35% range of crop fields that we wanted as priority. Again, there's other ways you could do this. The sites the livestock sites, those are independent of these crop fields, and those would be priorities in the watershed plan as well. The filter strips that I mentioned, we didn't take that into consideration, but that is something that could be a priority, just going to those fields that are within 50 feet that didn't have filter strips, and working with the farmers on getting filter strips and potentially other practices as well, tillage practices, nutrient management and such. So that's the inventory process. This map here is just showing kind of where we're at in the Western Lake Erie Basin on this process. The sub-watersheds that I was talked about over kind of in the southwest corner there, Covell, Lime Creek, Selzer, those are the ones within Bean Creek where the ag inventory is done. And then the rest of these that are colored in are in different stages of the ACPF being done, working on completing the desktop analysis or the field inventories, or some version of those. So this is where we're currently working with the conservation districts. But in addition to that, we're working to actually have the ACPF tool run on all of the Huck 12 watersheds within Michigan's portion of the Western Lake Erie Basin. Hopefully that process for the ACPF component can be completed by the end of 2023 is what we're hoping for. And then we will, prioritize different Huck 12 watersheds as far as working with the conservation district staff to do the desktop analysis component, for them to go out and do the field inventory components, gathering that tillage, residue, cover crop data as well, and just keep expanding that out, covering as much of these Huck 12 watersheds in the Western Lake Erie Basin as we can. And then obviously all of this information, having the local conservation district having access to this information, so that when they go to work with the farmers that were identified as having, priority sites or fields, they actually have all of this information to use when they go to work one-on-one with the producers down in the Western Lake Erie Basin. So like I said, we're working to complete the ag inventories across the Western Lake Erie Basin. And one other component here that I kind of mentioned, but how this could be useful if we go out and we collect, we run the ACPF tool, we do the desktop analysis, the conservation districts collect the tillage and residue. They collect 2 years of that. Well, we can go back out, they could go back out in 3, 4, 5 years later, do the same thing again, and then we can track over time with this process kind of what changes are occurring as to the tillage practices, or where there's filter strips, or how many acres are getting cover crops utilized on it. So we're hoping to use it kind of as a tracking and to see what kind of progress over time is being made as well, with all the information that's being collected on such a site-specific basis here. So that's the ag inventory process. I do have one more slide. I want to show you probably the most important practice from a Western Lake Erie phosphorus perspective is nutrient management. We need to control soil erosion. We need grass waterways. We need reduced tillage, filter strips. But it's all going to start with nutrient management, and basically, keeping the phosphorus that's being put out there to grow crops, making sure that it's being utilized by the crops. So this is what I have up here is a demo that the Lenawee Conservation District's using in the River Raisin right now. And they're going to be working with the Hillsdale Conservation District and using it in the Bean Creek watershed as well. It's basically trying to work with farmers, to provide cost share for them to do, nutrient management practices that will maximize the phosphorus uptake by the crop and minimize the loss of phosphorus to surface waters. And they're doing that by getting to this precision nutrient management. So having the farmers do soil testing based on grids or zones down to 1 acre or 2.5 acre grids, so they know what each of those, because as you go across the field, there's the phosphorus levels are going to be different as you go across the field. So trying to come up with a prescription, putting only the amount of phosphorus on that you need to grow that crop on that specific area, that 1 acre grid, and then using variable rate technology to actually put the commercial fertilizer in this case. So you only put on the amount that each acre grid or 2.5 acre grid needs, which is going to vary across the field, which is why they need that technology of being able to spread that phosphorus at variable rates. And then in addition to that, we're having them go below what the current tri-state fertilizer recommendations are for phosphorus. So we're working with them to not, if they have soil test levels that are above 10 parts per million for phosphorus, that are not going to apply any phosphorus fertilizer on other than maybe a pop-up right in furrow, which is a very, very small amount of phosphorus. And so what we want to do there is show that, to see if those farms, what kind of impact does using those lower soil test levels, what impact does it have on their yields, but also on their profit margin per acre. And then what happens to those soil test levels over time as they start using that lower threshold? How long does it take to actually bring those soil test levels down? The whole thought process is, if they can still grow crops and maintain their profit per acre and don't have to put as much phosphorus out there, there's obviously less phosphorus then in the soil that's available to be lost to surface waters, whether that's through surface runoff attached to the soil particles or going down to tile lines. So that's an approach that's being taken. Again, nutrient management is probably the key tool, that the number one thing we have to be addressing. Can't ignore the soil erosion, but we need to really be starting with the nutrient management part of it. So I'll go back to the last slide here, and that'll wrap that up, and I'll turn it back to Michelle if there's any questions.
Yeah, great, Thad. Thanks for that presentation. We do have a few questions here that I'd like to present to you. The first one is there any tracking of grass-fed livestock operations, or are they lumped into the AFO category and not counted or located at all?
Yeah, we did not distinguish between pasture operations versus livestock that were just confined in barns and such. The only thing we would have identified, if there was pasture operations where they may have had, the livestock had access to streams, ditches, or stuff that may be causing water issues, those would have been identified, but did not break it out into confined operations versus pasture operations.
Okay. Next question. How often are these data updated? So much important information, but they assume there is some level of change over time related to like cover crops, tillage practices, manure spreading, and lots of work, desktop and field. So how often are these data sets or information updated?
Right. So for most watersheds, we're only in the initial collection of this data. We do have one watershed as far as the tillage and residue, the La Pointe drain down in Monroe, where we have 4 years of the tillage and residue data, because that was the first watershed we actually collected that in. So we had 2 years from, I think it was 14, 15, 15, 16, and then there's two years more recently that were collected, so we can kind of compare. There was almost 4 or 5 years difference there, but everywhere else we don't have that yet. We're just a point of collecting the initial. But yeah, the desktop analysis, obviously with aerial photos, you can just go to Google Earth and you can see multiple years of aerial photos, and those are updated usually at least every 2 years, if not annually. So that could be done. We're thinking probably 4 to 5 years for the tillage and residue, going back out every 4 or 5 years and kind of comparing, to the previous data to see what's changing over time. If there's technology, satellite technology to actually start, instead of having to go out and drive the watersheds, if we can get satellite technology to get photos and more frequently, we might be able to pull some of the tillage and residue off of that. So it would be easier to do, less time consuming, and could actually be done as more like part of the desktop analysis than actually having to go out and drive the watershed. That's something that we're looking at to try to streamline that process, but that's going to take a little bit of time.
Yeah, good question or good response. Thanks. So the next more of a question comment was around how are producers responding to this process?
So that is a good question, because we're at that initial phase, and we're probably going to start seeing that. I mentioned the Bean Creek watershed. We have a Nonpoint source grant that we've given to the Lenawee Conservation District, working with the Hillsdale Conservation District. That was the first place we ran this tool, and they are now going to be using this information. It is a different approach. It is not just putting out news articles or sending postcards or letting farmers know that they have cost share. This is taking those priority fields, figuring out who owns them, who farms them, and being more proactive in going out and talking to them. And so it is a different approach. And it's still, with our grants, it's still voluntary. It still comes down to who's willing. So I guess that is going to be the key. But I think we're just at the initial phases of basically taking the information and trying to use it to implement now.
If I may just add too, Thad, MDARD has hired on 4 conservation specialists that will be nested within the counties to work directly in those priority sub-watersheds that have been identified.
Yep, and those, so we have permanent staff there that MDARD's paying for at the conservation districts to do that. And in addition to, the Nonpoints, our programs, watershed projects down there are kind of overlapping a lot of those areas. So we have the state, at the conservation districts, we've got staff dedicated to basically utilizing all this information that's being gathered.
Okay, that's good. So another question here is, do you have any issues with privacy? We've tried to map where we have CAFOs in Connecticut, and we've had a hard time getting that information due to privacy of farmers. We need livestock counts.
The CAFO information, like I mentioned, since at Eagle and Water Resource Division, we permit CAFOs, we have that information, and that information is all publicly available as well. In the information that we're collecting, it's all gathered through looking at aerial photos, Google Earth, driving watersheds. So everything is being collected as information that anybody can go out and collect if they want to spend the time doing it. So we don't have access to anything that's private information. It's all anybody who wants to take the time and effort. This is all information that anybody can go pull together themselves.
Next question. If you are varying the rate where levels are being maintained below agronomic need, is the VRT or variable rate technology based on crop yield, or is it still trying to address variability in the soil?
So that's a good question. So the variable rate technology, it is based on soil testing, and it is based on yield. The amount of phosphorus that you will apply will be based on yield goals. So whether or not you apply it, number one, is based on, in the example that I showed at the last slide there, 10 parts per million Bray P1 soil test. So if you're above 10 parts per million, you're not putting any on at all. If you're below 10 parts per million, then the amount you put on would be based on what your realistic yield goal is for that 1 acre grid or 2.5 acre grid, depending on how you're soil testing. So it is yield goal dependent. So part of that is knowing what's the potential productivity of any one of those grids. And that's where, farmers having yield monitors and knowing what kind of yields they can get over time, the more years of that data you have, the better yield goal, information that you'll be able to plug in there.
Another question here. In Ohio, we hypothesize that legacy or very high soil test phosphorus fields might contribute at higher rates. Do you plan to include soil test phosphorus levels in your field ranking analysis at some point?
We've talked about that. The problem is having that information. That's the one thing that you can't look at aerial photos. You can't drive around the watershed, know what are the soil phosphorus levels, what kind of nutrient management are those farmers doing. It's just that takes somebody at the local level working one-on-one with the farmers. One thing we do have, and we've talked about integrating it into this process, is for the CAFOs, actually we do have those soil P levels, because that is information that they have to report to us under their CAFO permit. We haven't gone there yet because the data, it's a lot of old data, and with the new CAFO permit that we're hoping is going to be issued and used soon, that's going to change what we have access to. So we were kind of waiting for that to happen, but that is critical. No question, that is probably one of the most important issues. It's tied to the nutrient management, is what are those soil phosphorus levels? Where do we have high legacy P in those, which of those fields? Again, that's one of the first things that the local conservation district technicians should be talking to these farmers about. Is their nutrient management? What do their soil P levels look like? Yeah, I wish there was a way we could factor that in on every field, that we could see it on aerial photos or something, but.
Great. We've gotten quite a few questions around cost share, incentives, BMP. Would you feel comfortable fielding some of those?
Sure.
Okay, great. First, I want to circle back on a question that related to the soil test levels that you had just mentioned. So regarding the demo field project. So no P added if soil test levels are over 10 parts per million. That's incredibly low. Are there trials already being done by MSU or OSU with lower amounts in corn specifically, for corn specifically?
I don't know if there's trials being done. So the tri-state fertilizer recommendations, those were updated in the last 2 years, and they actually lowered their soil phosphorus levels, and when they updated them. And yeah, we're going a little lower, and that's based on the conservation districts working with agronomists down in the Lenawee County area. That there's agronomists saying they don't think that those levels need to be that high, that their profits per acre, that at that 10 parts per million, they're going to maintain it. That's why we're doing it as strictly as a demo. We have built in there that while the farmers are using those lower levels, if they actually lose, their yields go down, and their yields go down enough that they lose profit per acre, through the cost share, we're going to compensate them for that. So there's no risk on those acres. Now, we're only going to be doing this on 2 or 3 or 4 of their fields. We're not doing it across their entire operation. It's basically, it's kind of doing research. The farmer's doing research on their own fields, because if they see what impact it has on their bottom line, what impact it has on their soil test levels over time, and if they actually can use those lower levels, the fact that they did it on their own fields, it's their information, they saw the impact, we think they're going to be much more likely to utilize that going forward, rather than research, say, from a university, which may be a small plot somewhere, or who knows what. That's the concept behind it.
Okay. Great. Another question regarding BMP implementation. How receptive are farmers to grassed waterways, filter strips, and other pollution reduction BMPs? Are farmers more receptive to nutrient reduction projects? And then do you have any tips for proposing such projects to farmers? How receptive are farmers to grass waterways, filter strips, and so forth? Mm-hmm.
So farmers are going to be more receptive to nutrient management if they can get the yields and the profits per acre, and and put less fertilizer out there. They're going to be receptive to that. Their drainage water management practices, where they're holding water back in the tile lines, that's actually, they could see potential yield increases because there's more water in the soil profile for the crop during the growing season. So it's easier to sell them on those practices because you can show from an agronomic perspective, from their bottom line perspective. It is harder to sell the grass waterways, the filter strips. The grass waterways, to be honest, I think it depends on who you have at the local level working with those farmers, because there's certain parts of the state, there's a lot of grass waterways. And it was just having somebody there to work with them. A lot of times the farmers will get tired of having to drive through the gullies and try to fill them back in, so they'll put them in. Filter strips usually takes more of an incentive to get them to put those in the Western Lake Erie Basin. The state has a agreement with USDA for the Conservation Reserve Enhancement Program. MDAR is working with NRCS, so there's pretty good incentives out there for farmers to install these filter strips, get paid per acre to do that on an annual basis, to keep those filter strips there. But there's no question, it's certain practices, it is harder to convince them to use than others.
Okay, great. Another comment and question appears the focus is on surface water runoff. One of the biggest issues is loss of soil structure and biology, which has reduced infiltration of water back through the soil profile. Has there been any preference given to practices that help restore soil health versus just nutrient management?
No, I totally agree with the soil health is definitely an important issue. Nutrient management is where we need to start from the phosphorus standpoint, but I would totally agree having reduced tillage, cover crops, building that soil health. As you increase that soil health, your risk of runoff and erosion are reduced, your risk of nutrient losses are reduced. So those are our practices. Like I said, we can't ignore the erosion part, but we need to make sure we're starting with the nutrient management, but address those other erosion issues as well as soil health, definitely.
Okay. Kind of shifting away from BMP implementation, do we know how much the studied watershed contributes phosphorus to the total phosphorus loading in the Western Lake Erie Basin?
There's not enough monitoring stations actually. So there's Heidelberg has monitoring set up near the mouth of the Raisin. So we have long-term data there, but that's basically the entire River Raisin watershed draining through there. So within the last year, Eagle has actually paid for USGS to set up gauge stations and to do monitoring in 4 Huck 12 watersheds, much smaller than the River Raisin. Where we're doing this process, one of those is one of the direct drainages over, it's LaPointe Drain in Monroe, so direct drainage into the Lake Erie. There's Stony Creek within the River Raisin watershed in Lenawee, which has a more livestock in it, that has a USGS gauge monitoring station. Niles Drain is more of has less livestock, so it's more commercial fertilizer. And then Lime Creek, one of the examples in the presentation, and the Bean Creek has a E. coli Tyndall has phosphorus issues as well, and we have a gauge station there. So our hope is with those gauge stations and starting monitoring now, trying to go through this process and implement practices, because we're monitoring at a smaller scale, at a Huck 12 scale versus at a River Raisin watershed scale, that we will be able to show, change over time. But it takes time, and it takes a while before I think we're going to see that.
Let's see here. Well, Ryan, I think we're down to there's some questions that might be a little bit out of context for the webinar. But one question that did come up is there a paper on the methods that we're using to develop this agricultural inventory process?
So one of my co-workers who helped develop this process says we keep needing to write a paper, and we have the process kind of down as to how to do it. We've trained conservation district staff on that, but we actually haven't, there's not a paper written on that kind of lays out everything. I'm guessing that will be something we will be we will be working on. Again, we started this kind of for Nonpoint source grants, and we've kind of adopted it here as one of our major approaches as to dealing with the phosphorus issue in Western Lake Erie Basin.
Mhm. Great. Well, thanks, Thad, for the presentation and all the great questions. I'll go ahead and turn it back over to Ryan to close us out.
Thanks, Michelle. Yeah, thanks again, Thad, and for answering those questions, and for all of you for submitting them. Last thing I just have is I want to let you know we'll be sending a couple emails your way. First one will have a certificate and a survey for this webinar. The second one will have a link to the recording, so you'll be able to watch it again if you choose. With that, yeah, thanks again, everyone, and I hope you all have a great rest of your day.